Boom! Yes folks, Hume again. In this video, we're going to continue in the series of completing the square. In this video, we're going to use the result derived from the previous video to do something else. So in the previous video, we would have completed the square on the general quadratic expression, and we moved from the standard form ax squared plus bx plus c to the vertex form a into x plus b over 2a all to be squared plus 4ac minus b squared over 4a, which is in the vertex form. And this we would have used to derive values for h and k, values that people use when they are employing what I like to call the short method or the shortcut method to complete the square. I, of course, would have used the long method to get from ax squared plus bx squared plus c to this. So we're going to use this result, and we're going to use that result in the solution of the quadratic equation ax squared plus bx plus c is equal to 0. So the actual equation we have, right, just as we just call it out there, ax squared plus bx plus c is equal to 0. So the method we employ is the method of completing the square. So we complete the square on this to transform it into something else that we could use to actually find the value of x. Because if you notice, you have an x squared here and you have an x here. So if you try to factorize this, which is what a lot of people would try to do, you wouldn't really get too far. So for example, there are people that would try this. They would say x into ax plus b plus c, and then they'll carry the c across equals 0, and then they'll carry the c across, and then they'll divide by x. But then that wouldn't make any sense, because you have an x here and you have an x inside there. Let me just carry this through just to show you. So some people will do this, and then they will say x into ax plus b is equal to minus c, and then they'll say x is equal to minus c over ax plus b, which in terms of raw technical steps is true, but it makes no sense if we're trying to solve x, because what we're actually doing is making x the subject of the formula, which means that x alone must be on one side of the equation, and we don't have that here. We have x here and we have x embedded within this expression ax plus b. So this is clearly not an option, right? The equation as it stands there is a general equation. So we know absolutely nothing about the values of a, b, and c that would give us a clue of what method we could use. Usually when we know the values, we could tell whether we could factorize it. We could tell whether we could factorize it or not. Right? We could tell whether the solutions would be real or imaginary. Right? If the solutions are real, we could tell whether they would be real and distinct, or whether they would be real and equal, etc., etc., etc. That's other stuff. We're not dealing with that now. So in the absence of any further knowledge as to the values of these constants a, b, and c, remember x is a variable, we have to do something else. We have to employ some other mathematical technique that will allow us to get a general solution for x. That technique, if you have not guessed by now, is the technique of completing the square. So we will complete the square on this. We will complete the square on the expression here, equate the result to 0, and then we will use that to derive a general value for x. So remembering, of course, that that is exactly what we did in the preceding video. So we're not going to repeat all those steps here, right? You could always go back to the preceding video and check it if you like. We will just use the result. So when we complete the square on this, we know that this here in red is what we will get. So I could immediately go here for the sake of explanation and say, therefore, a into x plus b over 2a squared plus 4ac minus b squared over 4a is equal to 0. So now we have a situation where if you have the eyes to see these things, you see that you have x alone here by itself, as opposed to here where you have x squared here and you have x here. So in this form, we could take a series of steps that will isolate x on one side of the equation. That is what we refer to as making x the subject of the formula, or in more regular language, we solving for x. So the first thing we want to do is take this whole thing here and carry it across on the other side of the equal sign. So the next step will be to say that a into x plus b over 2a squared is equal to, and if we take this across, remember we changing the signs. So minus b squared will now become plus b squared, and 4 plus 4ac will now become minus 4ac. So when we carry that across, this will now be, I will take the long route just for the sake of explanation. This will be minus into 4ac minus b squared over 4a. So we have an expression that gives us the first steps towards, we have an equation, that gives us the first step towards solving for x. So this is what we're going to have, this is what we have here. So I'm going to go up on top now, erase what we have there, and change the color of the ink just for the sake of fluidity in terms of following the steps. So we could take this out of the picture now, and I will remove that also for clarity. So minus into 4ac minus b squared is the same thing as minus 4ac plus b squared. So we could put the plus b squared in front and we get b squared minus 4ac. So that the next line I could write on top here, I could put that as a into x plus b over 2a squared is equal to b squared minus 4ac all over 4a. And for those of us who would have had some level of exposure to maths where we're dealing with quadratic expressions, you would recognize, you start seeing something that you would have seen before. B squared minus 4ac. So you're seeing something taking shape here that they have some level of familiarity with. So let us continue with the work it. So the next step here is to, let us see, we cross multiply, we divide by a on both sides. So we take the a and we bring it underneath here. So when we cross multiply, the a we multiplying by a on this side, which means that on this side we will be dividing by a. So that your next line here would be x plus b over 2a all to b squared is equal to b squared minus 4ac all over 4a squared. Alright, so we've seen something taking shape now. Something that we're kind of familiar with. Alright, so if x plus b over 2a all to b squared is equal to this, then naturally we could take the square root on both sides and we could get that x plus b over 2a is equal to, watch it now, plus or minus the square root of all of this, b squared minus 4ac all over 4a squared. So you've seen a certain thing taking shape here, which I'm not going to mention until the very end, but you will know exactly what we're talking about. And of course, again, I'm going to go above now. So you have the video, you can rewind and check it. So I'm going to go on top here now. I'm changing the ink again. This time we're going to go, let us go red. So we could say here now that x plus b over 2a is equal to, now the square root of all of this will be equal to the square root of the numerator over the square root of the denominator. So that is equal to plus or minus the square root of b squared minus 4ac over, put this in a kind of general position here, over the square root of 4a squared. Right, things that didn't happen now. And of course, we could see now that x plus b over 2a is equal to plus or minus, this will remain as is, the square root of b squared minus 4ac all over the square root of 4a squared is 2a. Well, look, it looking like something we recognize, right? So now we could take the b over 2a and carry it across on the other side. So that what we will have now would be that x on its own is equal to minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And remember from previous discussions, and we would have mentioned this repeatedly in the series of videos on completing the square, when you have two fractions with the same denominator, as we do here, minus b over 2a, 2a is the denominator here, plus or minus the square root of b squared minus 4ac all over 2a. 2a is the denominator here again. So when we have two fractions with the same denominator, we have the liberty, we have the luxury to perform all the arithmetic at the level of the numerator on top. So what we now have is that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And that is what we know as the quadratic formula. So again, we would have demonstrated here, we would have gone through what we could refer to as a proof or a demonstration. Two different things, eh? But at this stage and at this level, we could use the terms kind of interchangeably, but just bear in mind that a proof is not the same thing as a demonstration. I could demonstrate something working without necessarily proving it. A proof is usually a much more elaborate and involved bit of mathematics, and usually the proofs involve mathematics at a higher level than the level that you're operating at. So don't get too caught up in the jargon and the semantics. Just see this for what it is, which is we're showing you how the thing works. So we would have shown that we can use the completion of the square, what I like to call the long method, where we divide by the coefficient of x squared, etc., etc., etc. We use that method to solve, to get a general solution for the quadratic equation ax squared plus bx plus c is equal to 0. And remember, we would have spoken about having two solutions. Well, guess what? You have the plus or minus here. So what that means is that you have two solutions where one solution is, and I'm going to squeeze it up inside here now, one solution is that x is equal to minus b minus the square root of b squared minus 4ac all over 2a. The other solution, of course, being that x is equal to minus b plus the square root of b squared minus 4ac all over 2a. Now, of course, for most intents and purposes, you don't need to be able to do this to use the formula. Usually what will happen is that you will get a quadratic equation, and once you can determine that the quadratic equation is not factorizable, usually they will give you a hint to suggest that. Right? They will tell you solve to 2 decimal places, or solve to 2 significant figures, or something of the sort. That is a hint that the equation is not factorizable. And generally speaking, if the equation is not factorizable, if a quadratic equation is not factorizable, we just go straight to the quadratic formula. So what we have done is demonstrate that the quadratic formula comes from somewhere. It comes from some place. It is not some random hodgepodge that somebody sitting down in a dark corner and just put together and say, here, take that. Right? There is a particular reason, a particular logic, a particular flow to the thing. All right? So again, this arithmetic that we just went through here is not necessarily something that you would need for the purposes of passing an exam. But if you could follow this and understand it and enjoy it, then you're in a very good place where maths is concerned. It means then that you could just flow into other areas, right? First of all, with this topic of quadratic expressions and quadratic equations. And then, of course, you could take that down over into other areas in mathematics. And the hope, of course, is that you could take that mentality, that attitude into other non-academic, into other non-mathematical areas of your life. So, with that said, we bring this video to a close. I hope that you would have enjoyed this video. If you did enjoy the video, spread the word, stay tuned and look out for more. We have plenty more coming your way.